Okay, hello. So these are your video notes. So go ahead and write your title. You want to title this Unit 3.42, Graphing Quadratics and Graphing Systems. Okay, so you're going to need this vocabulary a lot next time that we meet. And some of the vocabulary that you'll see in next class period is systems of equations, linear equations, and solution point. Okay, so all of these additional vocabulary words are just parts of a parabola that we need to review. Some of us understand this and remember some of these words. Some of these are Algebra 2 words, so some of them may be unfamiliar, but the goal of this video is for you to come prepared with knowledge of each of these vocabulary words and how they relate to a parabola in graphing quadratics. Okay, so here we go. Our first vocabulary word is axis of symmetry. Okay, so right here we can say the axis of symmetry will always be a vertical line. Okay, so as you're writing your notes, you want to make sure you write axis of symmetry, have this statement right next to it, and then you want to draw this diagram and this parabola as well, because you're going to annotate this in your notes. So the axis of symmetry will always be a vertical line, and in the x equals c form, and c would represent a constant number. Okay, constant number. Now, on the graph, how you will see this, let's just say you drew this graph here. So I'm gonna kind of like do this piece one more time. And that's x, and this is y. Oops, I'm gonna actually, okay. And this is y. All right, so the axis of symmetry, so if I were to kind of have you all see this, it's actually this dashed line right here. You have to eventually do this. This one, they did it for you. Okay, so this dashed line, I'm going to kind of put it off the chart so you can clearly see it a little bit more. That is the axis of symmetry. So the way we write this, we say x is equal to whatever value we have here. In this case, it's -1. All right, so this is 0, 0, and then we have -1. Okay, so on the graph, we can say that the axis of symmetry is x is equal to -1. So you can call this as example graph. I'm going to be referring to this a lot in our video. Okay, so then in our example, in this case, we would say the axis of symmetry is x is equal to -1. So axis of symmetry. Okay, next vocabulary word is our vertex. Now, our vertex is a little bit different than the axis of symmetry. So the vertex is the either maximum or minimum of the graph, and it's usually in the form of a coordinate point. So usually in an x and y coordinate point. So you could, or actually no, you can't. This is how we would like for you to write your vertex. It should always be as a coordinate point. So how do we find the coordinate, the vertex in our parabola here? So I'm going to use this in red. That's going to be this point at the very bottom. So we can see here that this actually has a minimum, right? So in our example, we have a minimum, and the vertex is at when x is -1, and then when y is 1, 2, 3, 4, -4. So -4, -1 is our vertex, and that's all you have to do. Okay, so we're just labeling all of these different points here. Okay, so we talked about axis of symmetry, talked about vertex. We're moving on to identifying roots, solutions, or zeros. Okay, these are all the same thing. So whenever I'm referring to roots, I'm really referring to solutions, and I'm also referring to zeros. Okay, so in this case, we can say the roots are also known as zeros or x-intercepts. And the roots are usually in the form of, you could say, there's two forms for this one. You could say x is equal to c, like the constant, or you can say, or it can be in an x and y coordinate. This method is, or this form is more preferred, making sure that you write it in a, as a point. Okay, so zeros represented as a coordinate point is preferred. Okay, so then let's go ahead and identify the roots in our example here. So here we have, this is the example. I'm just keeping the colors the same. So we go ahead and find our zeros or x-intercepts, and they already have that labeled for us. So here's one root. So at this point, this is 1, 0. And then we have another 0 or root or solution, which is at 1, 2, 3. So then -3, 0. Okay, so in this case, we can say our roots. There's two ways you can do this. You can say x is equal to -3 and x is equal to 1, or you can write it as -3, 0 and 1, 0. And that's it. Okay. Now, range is another vocab word. And this one is a little bit tricky. So if you still have questions about this one, that's okay. I understand. I'm going to explain this one as best as I can. But the range is an inequality or an interval. Okay. All this really means is that it's a collection of y values. Okay, so at what range does our parabola or our quadratic focus on in terms of the y values? So right here, we can say this is also a collection of y values. Collection of y values. Okay, so then here we can say that it starts at the vertex. Okay, it's not the vertex, but it starts there. So if we start at the vertex, well, let's go back. Our vertex was -1, 4. So I'm going to do this in green. So collection of y values, and it starts at the vertex. Okay, so what this means, the best way I can try to explain this to you, if you were to like draw kind of like a line, a dashed line right here. This is just a temporary thing, right? Notice that our graph is not going below this line. So right here, this is representative, right, of -4. So 1, 2, 1, 2, 3, 4, right? This is -4. All of our graph is above that value or at -4. So that means that our range in our example is it could equal -4, or it can be any value greater than -4. So the best way to represent this is with an inequality, which is what we've highlighted right here. So in this case, we can say the range is y is greater than or equal to -4, and that's it. Okay, so again, just means that our graph is above or touching -4. It includes all y values at -4 or above -4, but not below. Okay. All right. Concavity. So this one is our next word. So this one's pretty easy to spot. Here, basically, if you have your concavity, how it looks like visually, if your parabola is ending towards positive infinity on both sides, so let's say this is positive infinity and positive infinity, like the endpoints are going in that direction, that means it has its concavity is positive, right? So then the way to see this algebraically, it's when the leading coefficient coefficient is positive. That means the shape of our parabola is going to be upwards. Okay, so it's going to basically have like a smiley face. Okay, but for instance, if we have one that's going in the opposite direction, so both ends are going towards negative infinity, then this is when the leading coefficient is negative. This is when it's negative. So in other words, the leading coefficient is the A value when we are writing our quadratic in standard form. So just so you all can see that as well, standard form is ax squared plus bx plus c, right? And usually that would be equal to 0, but in this case, what I'm referring to as the leading coefficient is this a value right here, right? So basically, when this is your leading coefficient, and so we can see this connection. So when the leading coefficient is positive, so if we have a positive a value, then we know it's going to be in this shape. We know that both ends are going to end towards positive infinity. And then here, if the leading coefficient is negative, for instance, then it's going to face downward towards negative infinity. Okay. So that is it for right now. I just want you all to get familiar with these vocabulary words. So making sure that you go ahead and write your summary down below here. And I guess I forgot to write the example for this one. But the example for this one, we can see this is concave up. So we can say in our example, this has it's concave up, and that means that the leading coefficient is positive. Leading coefficient is positive. Okay, so that's for the example piece. All right, but other than that, you should be good to go. Write your summary, write any questions that you have, be prepared to apply this knowledge in our next class, and that's it. Bye.